Okay, cool. Hi, everyone. My name is Fred Chung. I'm with Android Developer Relations team at Google. Welcome to droidCon Americas Day 1, and also welcome to this talk about updating your apps or adapting your apps rather for privacy changes in Android 11. I'd like to give everyone an overview on privacy. Basically, it's an area that's been evolving over the last several releases of Android, and we are continuing to do so on Android 11. The scope of these changes includes updates for users as well as for developers. Now, this presentation will touch on some user-facing changes, but we'll focus primarily on developer issues such as new APIs, behavior changes, and for those that do testing, we're going to touch on some testing considerations as well. I wanted to share three things that drive Android's design for privacy. We want to give users control on when and how much of their data is shared. At the same time, it's important to provide transparency through the system and in-app user interfaces. Now, for developers, we wanted to provide some guardrails to help you design your apps such that they only access the least amount of data needed for the use case. These include platform support as well as developer guidance. Now, in Android 11, we've continued to innovate in privacy improvements, as I alluded to earlier. They are related to permissions, storage, and access to installed packages. We also added some APIs to help you identify potentially unexpected data usage. Now, all of these were designed to offer better control, transparency, and help developers use data responsibly, as I mentioned earlier in this talk. And now we wanted to talk about one-time permissions, something new in Android 11. When users are given a choice, they are choosing to share less private data with their apps. As you can see in this screenshot, I've captured this screenshot on Google Play Store from a real user rating. It's a low rating, 1 star, and it's upvoted by at least 10 people. And the key thing here is that for this particular commenter, they wanted to remove the permission, but for some reason the app is designed such that it doesn't function. So this user, rightfully so, is getting upset. So we saw that there are apps that request background location access, but with no need for it, or don't explain why, as illustrated in the comment. As a result, as I mentioned, it's a 1 star. So let's have a look at how best to design your app to sort of avoid these situations. So we asked our end users, apart from location data, what other types of data are important to them? Based on the feedback, apart from location, they wanted to also care about camera data, which is super private, right? As well as microphone access. So we are bringing more granular control over users' private data, and we are significantly limiting access to background location. Now, let's have a look at a real use case. Users will be able to grant temporary one-time permissions for location permission requests. And also for microphone access, as you see on this screenshot. Suppose this is a chat app that it's rarely used. User can make voice-only calls. They have the option to not permanently commit to the record audio permission. Similarly, for camera access, right? So in a VoIP app, you can also use camera to share your image with people that you're talking with. If the same app also supports video calls, the app would record video permission. Now, you may have this very, very important question in mind, which is, do I need to make any changes? And if so, what? And the good response is that there's nothing that you need to do, but there's a caveat, which is so long as you are following existing best practices. So what are those existing best practices? Here we go. Let's have a look at a quick code snippet, which hopefully for a lot of developers out there watching this, you're already familiar with this pattern. So the user taps on location button. So what happens here follows permission request best practice. The pseudocode on the left illustrates the pattern that I just mentioned. Let's have a look at it in more detail. First, we check if the permission is granted before accessing private data. When this is first run, chances are it isn't granted. Next, we let the system decide if a rationale or show an in-context UI explanation is needed. Normally, not always, the first time the system will consider that this is not needed. Now, I think this is really dependent on how the app's UX is designed. In some cases, if your UX is designed clearly so that the user understands that in context, hey, I'm about to access a feature that requires a location access, then the user is more likely to provide such access to this application. Now, so after checking if the app has access and show a UI explanation optionally, you can go ahead and request the location permission. This prompt the system. This causes the system to prompt a UI with these three options. Now, let's say if the user decides to deny the permission for this particular request. So what happens? In this case, in the on request permissions results callback, which again, for a lot of existing Android developers that have been doing Android for a while, you probably should be familiar with it. If the permission was denied, you'll get a callback. And in this callback, you can decide what to do. One suggestion is to make sure to explain which functionality won't work because of this denial decision by the user. In this case, we could show an explanation, for example, in a snack bar to indicate that the functionality is not available. For example, in the VoIP use case, if the user has denied access to camera, you might want to pop up a snack bar to tell the user, hey, in this particular VoIP session, you won't be able to display your video to the other party. Now, also more things on locations. On Android 10, we introduced the separation of foreground and background location permissions. There's no change to foreground access requests. This will be adequate for most use cases, whether for your use case, if you need fine location or coarse grain location. Now, this is a little bit more complex. For applications that target API level 30 or Android 11, so this is something for you to consider. Most location use cases can be done with foreground location, okay? We think that if the app is visible to the user, let's say in an activity or in a foreground service, that could be used to fulfill most of the location use cases. Now, if you think that background location is really something for your application, it's good practice to incrementally request permissions to give users a chance to understand and decide based on context. Let's have a look at the diagram on the left. Let's say you've gone ahead and requested location permissions from the user. They'll see this familiar dialog box. If they click yes, they would continue using the app until they hit a point that requires background location access. Then, as an application developer, you can selectively decide whether it makes sense to show an in-app explanation to the user, as shown on this in the middle diagram. Now, if the user clicks on update settings, what happens behind the scenes is that your app could still invoke the request permissions API by passing in the background location permission string. So the system is designed such that it would redirect the user to app settings in order to complete that selection instead of popping another permission dialog. And this is specifically for background locations. Now, it is strongly recommended that the UI is shown based on should show permission request rationale API as we talked about earlier. Now, one interesting thing, or one important thing rather, is that in the middle diagram, in the explanation, it's important to include a positive as well as a negative action for the user, so that it really causes them to think through the scenario and decide deliberately whether to deny or approve a certain permission. And one other note is that on Android 11, the app settings screen for granting background location allow all the time screen is rate limited, so that when a user denies multiple times, that UI won't be shown upon triggering request permission API. So it's something to consider as developers. Now, I wanted to call out, in particular in your testing, is that since the request permissions API takes a string array of permissions as input parameter, chances are in your code, you may have a pattern that looks like this. In this case, it attempts to request permissions for both foreground, coarse or fine, and background location. In order to enforce the best practice to separate these location requests, we've made this an enforced behavior on Android 11. If this app happens on a particular Android 11 device, this particular API call will get ignored. And I think, yeah, so as you carry out testing in your application, it's always good to scan for similar patterns. And also one note is that if in the same call, you also happen to have a camera permissions as well, any non-location related permissions requests will also be ignored. So keep an eye out for this situation. Now, in order to avoid the situations where the user installed a particular app that they don't use on a daily basis or often, and they might have previously used it once or twice and granted certain permissions. And after a while, if you don't use an app for an extended period of time, the user may forget. In order to minimize the situations of unexpected access to private data, we've added something called auto reset permissions to Android 11 for apps that target API level 30. Which is if the app hasn't been used for an extended period of time, the system will go ahead and deny the permissions, any previously granted permissions for the particular application. So how do I, as a developer, handle this? So again, if you are following existing best practices by checking for permission access before attempting to request a particular private API, sorry, not private API, but APIs that accesses private data, then you should be fine, right? So, so this particular dial or settings that we are looking at here is in the app settings for the particular application. Now, we do wanted to provide a way for a class of special applications to get out of the scenario, or guide users to go into app settings and undo these auto reset behaviors. But keep in mind that for this is really meant for certain types of applications. For example, apps that provide family safety, or apps that synchronize data in the background. There's this action that's called auto revoked permissions that you can use that would redirect the user to that settings screen to toggle auto reset for the application. And now let's talk about a new support for apps to discover potentially unintended access to private data. So if you're working on a large-ish application project, when you ask this question, why did my app use that data? Chances are, if you ask yourself or if you ask your colleagues on the engineering team, they may have a similar response like this: I want to know, but I didn't write the code, or they basically wanted to blame others. So in order to help with these scenarios, we've come up with data auditing API. Let's go through in a little bit more detail what this is. So let's consider, you have a bunch of code on the left. So especially if you are working with large code bases, where there's multiple contributors, and over time, it might have accumulated some orphan code that are not maintained, or if you're working with large teams of developers. It's not uncommon for you to get into scenarios where any access to private data is not fully known by a lot of developers working on the project. Okay, and then another scenario is that chances are you might be using some third-party libraries that could either be open source or closed source. It doesn't really matter in a lot of large projects. You just don't have enough time to fully understand every single line of code, be it in your code bases or in third-party libraries code bases. So in these situations, access patterns to various sensitive data like location microphones may not be entirely obvious, as shown in these spaghetti-colored lines. So we wanted to fix that, or at least help developers mitigate these situations. Whenever an app calls an API that returns private data, the system calls into a collection handler immediately before returning to the calling code. And therefore, at this time, the collection handler can collect a stack trace to record which code performed the access and so forth. Let's have a look at how the API works. So in this code snippets, this shows how to set up a callback for data access through the AppOps Manager class. If you want to consistently track it for the entire app, you can use it within application on create. But let's say if you wanted to localize it to a particular portion of your app, you can potentially add this to your activity.onCreate method. Now, within the onNoted callback class, your app will be notified of data access in synchronous calls. When this happens, you may log any stack trace or send some anonymized data back to your backend for further analysis. But if you were to do so, make sure you let the users know in your prominent disclosure on the fact that you're using this data and what you're using this data for. Apart from synchronous access, this can also be used to track asynchronous access. For example, if you're using a few location providers in Google Play services, this can be used to also track any access to location data. Check out the API reference for more detail. Now, let's have a look at scenarios in a lot of complex applications. They often involve many different features or functionalities, as shown in the set of boxes in the middle, like navigation, explore shopping, and so forth. In Android 11, we allow for an app to attribute data access to a particular feature of the app. Basically, it provides some level of abstraction to help you better manage your callbacks. Each of the features uses a subset of private data. Let's say find friends feature as highlighted in green. Let's say it may not need to use a microphone, right? Having features as high-level concept compared to just areas of code makes it easier to find what features have accidental data accesses. Further, this will make it easier to explain to the user what private data is used for. Data auditing API allows you to attribute data access to features. Let's see how to use it. Now, to attribute features in your code, create an attribution context and give it a meaningful name that corresponds to your feature. For example, find friends in the example that we just saw. Then after that, you'll get back a reference to a context. And then you can pretty much pass this context to any APIs that requires a context object. Now, within the data auditing callback, remember we said that whenever your app attempts to, let's say, access sensitive data, for example, location data in runtime, this callback will be invoked. Now, as one of the input parameters for this callback, you'll have access to this field called attribution tag, and this will contain whatever name that you provide in the above code snippet, for example, find friends. And that's how you can associate various logical areas within your applications with any data access so that you can make certain changes as necessary or make sure you prominently disclose these accesses to your users. Now, let's talk about another topic. Foreground service type. Now, again, like for a lot of existing developers, I think foreground services is something that you are already familiar with. They are typically used for implementing ongoing tasks, such as downloading large files remotely. There are better implications, and you should use them carefully and judiciously. To provide better accountability for applications to access private data in the foreground service, the platform relies on something called foreground service type attribute in the manifest, something that we introduced in Android 10. This is a new tag that you could provide in the service declaration in your manifest. Apps can declare their intentions to access this info within its foreground service. Now, there's multiple types, but only a couple of types are enforced: location and media projections. There are a few other defined types, but let's focus on 3 today. Let's see. So we talked about location, right? But apart from location, in Android 11, we've also started enforcing the foreground service type for camera. So that is, if you are attempting to access the camera from your foreground service, you must declare this camera value in your manifest. And likewise for microphones, same thing. In the same surface declaration, you can declare multiple types. So just to recap, on Android 11, you need to define a foreground service type for any of these data: camera, location, and microphone. Now, let's move on to discuss next topics, package visibility and interaction. One note on interaction is that it refers to things like starting services or invoking the content providers from another applications. We wanted to find a way to help developers sort of limit how, if their apps can read other installed application package metadata on the device. This is obviously done to enhance user privacy. So for certain common scenarios, you don't need to make any changes. Let's have a look. Let's say you have your application on the left and other applications on the right. You can use Package Manager to query and interact with them, as I mentioned earlier. So if you target Android 11 or API level 30, this API will return package info for your own app as expected. So no change, which is good. And it's for this API, if you pass in a 0 parameter, again, we are talking about apps that target API level 30, it will return only the calling app, which is yourself, as well as a set of system packages that are needed for the core OS to function. Now, if you have existing logic that sends implicit intent for another app to take action, for example, if you wanted to um, pick a file or something, again, no changes are needed for implicit intent interactions with another app. In another scenario, if a different app wants to call your app's content provider and expects results, um, without making any changes, your app can query and interact those apps. Basically, if another app relies something on your app automatically has visibility to the other app. So besides the scenarios that we just discussed, by default, your system will return name not found exceptions if you attempt to discover a random third-party package in your source code. Let's go through a few scenarios and how to handle them. If you need to explicitly interact with another app, for example, invoke a specific service, or I should say bind to that service, use the new queries elements in the manifest to explicitly list out all the package names that you would like to discover. Or if you rely a lot on implicit intent, you could you could include the intent filters signatures. You can include one or multiple of them in the same new queries tag in your manifest to ensure visibility to those packages. And likewise, if you needed to interact directly with a certain known set of content providers, you could likewise include the provider tag in here. Oops, I missed the page. Now, as we saw, you can use this declarations in the queries tag to support most use cases, but we know that there are some use cases that actually need broad access, and therefore the system also comes with a special permission called query all packages. But again, try use it judiciously for things like browsers or security applications that truly need access to the entire list of installed packages on the device. Now, in order to minimize cases for abuse or abuse vectors, there will be some Google Play policies around the proper usage of this. So please stay tuned. Now, sometimes if a social or map or points of interest application fires a view intent with a certain URL, you want to be able to take users directly to a default native application that can handle the URL and possibly do it better than a web browser. If you just did this, your user will get a disambiguation dialog box, making the user experience non-ideal in certain scenarios. On Android 11, there's a couple of new intent flags, one of which is flag activity require non-browser. It ensures that the intent is only handled by a default native application. Now, if none of the default application is available, then it will result in this exception, activity not found exception. In the exception handler, you can choose to take over handling the intent. For example, if your app supports Chrome tab, then you can use Chrome tab web view to handle the content properly in your application. There's another similar intent flag called flag activity require default. It ensures that there must be one default app that can handle the view intent. Else, it also results in the same exception, so you can override the experience for your users. So with package visibility, I wanted to talk through one specific scenario. If your app is on the right-hand side, let's say if you have some application logic to share content providers, and these content providers can belong to your own app, or it could be based on some other providers, for example, contacts database. And on the left, there's a client app that you would like to share those content providers with. So what you could do is to call start activity and pass in an intent with the URI and a view action. But with things like package visibility on Android 11, regardless of target the client app's target API level, it doesn't work until you explicitly specify read-write permissions for the URIs that you intend to share with the client applications. This is important for you to think through. And regardless of Android 11, this is a good software development practice to sort of lock down your data just to specific applications that are intended to consume your data. To help you test out package visibility features, there's a couple of ADB, there's one ADB command that you can use. You can specify your own package name. Upon testing, you can check out logcat output to verify its result. Okay, let's move on to another topic. I wanted to give you an update on scoop storage. Just a quick reminder, before the introduction of scope storage in Android 10, there were two classifications of external storage: app storage and shared storage. Any apps with storage permissions had access to all shared storage content. This is regardless if you need to access your app-specific files other than those that belong to others. But for some users that really care about it, they get upset, and rightfully so. It doesn't make sense for a lot of apps to request access to the entire external storage if it just, for example, needs access to a specific folder. So how do we deal with it? The answer was scope storage in Android 10, right? In order to better scope external storage access, we changed this by adding distinction between media files and other documents. Rather than apps gaining access to the entire external storage, they now only have access to media files. And then there's separate collections for documents as well as downloads. Here's a specific set of changes in Android 10. We received a lot of feedback from developers. There's lots of good feedback, and as a result, we realized that not developers can make these migration changes as we rolled out Android 10 last year. So we also added an opt-out feature where developers can supply this attribute value in their manifest files. Now, in Android 11, we made some improvements in scope storage in a number of ways. First, we've made further adjustments to storage permissions. We also allowed the capability for applications to perform bulk editing and deleting of media files. Let's have a look at the actual APIs on how it works. You can first specify a list of URIs that you intend to interact with, pass it into this API call, then you get back an intent, you supply a pending intent and a request code. Then your user will see a dialog box for them to pick and choose which media files that they would like to make changes to. After that, in your code, in the callback, on activity results callback, for the corresponding code, you can then manipulate the selected files. Another change in Android 11 is that in the SAF, we've sort of added some restrictions to restrict how apps can interact with various folders. The folders that are crossed out cannot be accessed by applications with open document tree intent. And likewise, for open document intent, we've also crossed out a couple of folders that are considered to be used for storing sensitive information. Now, when it comes to direct path access, our general guidance is still to use media store APIs, but we also understand that in certain situations you might have existing code base, or if you're utilizing third-party libraries that might be relying on these code paths. In this case, we've sort of made it possible again for applications to directly access media files via file paths. So the general guidance is like this. So for Android 11, you can go ahead and use it. But since Android 10, we sort of locked it down, but at the same time, we provided this opt-out feature for users to revert back to the pre-Android 10 behavior. The recommendation, if this is something useful for you, is to opt out on Android 10 so that you get to use the Android 9 and older behavior. And likewise, for Android 9 and older devices, you have the legacy behavior. So we've also come up with a list of best practices for scope storage for different use cases. Check out this URL for more information. So one thing to note is that we realize that certain types of applications, like File Explorer type applications, do need access to files broadly, and therefore we've also included a special permission for apps to achieve that. But like the previous policy mentioned before, this is really intended for a selected list of use cases, and there's some corresponding play policy around it. Please check out the 2D barcode for more information. Lastly, I wanted to share with everyone some privacy best practices that we've prepared. And by the way, these best practices are not specific to Android 11. These are specific to pretty much any modern Android developer, Android platform versions. So please check them out. They are divided into different subsections like permissions, usage of location, and so forth. So with that, that's it for the presentation. Hope you learned something and enjoyed it. That's it. Thank you very much. So, yeah, we have a couple of questions. As a developer, how to make sure a third-party SDK being used is not using user privacy data? That's a great question. One thing that I would like to plug again is to try to use data auditing API. That is, if you're using Android, if you're targeting Android 11 users. But what about older devices? I think the best way is to work with your SDK vendors, and if you're using open source libraries, check out comments, or if you have the extra time, go through the source code. From a Play Store perspective, or a lot of app stores out there, it is the application developers' responsibility to ensure that their apps not accessing something that they shouldn't be, even though they are using third-party SDK. So this is an area that's important. So I encourage everyone to, again, like if you're using Android 11, if you're targeting Android 11 devices, use data auditing APIs. The next question, when can we expect Google Play policy update regarding query or packages permissions? So we are still, we don't have a timeline to share, but I think this is an area that the team is actively working on. So the next question, but I guess the general guidance is try to evaluate whether you can use queries packages. Sorry, the queries tag in the manifest to support your use cases first as a first step. Then, if your use cases fall under one of the categories that we showed, and by the way, the list of use cases that we shared on the slide, or we just spoke to, are not exhaustive, right? So this is just a list of example use cases. like I said, try to leverage the queries tag first. And if you're really stuck, you should please stay tuned and look for more updates on the policies. Is there any plans to add attribution to permission requests, like we have for data requests in Android 11? So I assume this question is intended for pre-Android 11 platforms. So since something like this is dependent on some low-level features on the platform, we currently only have the support on Android 11 plus. It would be hard to backport to pre-Android 11 platform versions, if assuming that's the question, that's the motivation of this question. So Android 11 and above. Cool. Well, thank you very much. Enjoy the rest of your day or evening.